I'm so mad. I'm so mad and sad. What happened was, last time I started doing this whole record my camera and the screen at the same time thing, and it was just, I guess, a coincidence that it worked, and it produced two files at the output that had the same timestamp name, and I could edit them together, and it was all great. This time, I had my two instances of OBS, and I clicked record, and uh, the camera one that has no audio on it overwrote the screen capture one, which has audio and the screen capture of all the problem solving. So I'll just have one video, which I'll cut to a clip of the little distorted fun thing here. Because I've still got all my session output here, I'll just sort of do a little run through of what happened. So the first problem is to count set bits in binary representations of numbers from 1 to n. And this was just super nice in APL. It like for several of the previous Perl Weekly challenges, I've used this phrase 2 base power neg 1 iota omega to generate the binary representations of numbers from 1 to n, where n is omega. And then I just sum down the columns because that sums the number of set bits, pardon me, in each number, and then you sum across. And then the next one I had two thoughts about. One was, oh, I know how to generate a histogram in APL. Not that often used anymore with modern graphics packages, but back in the day, with teletype terminals producing text reports, this type of idiom would have been very useful to generate a histogram, right? But the challenge itself was to do with imagine water pours into this histogram and it can fill up these gaps and then count the number of gaps, basically. So there's one here, and then there's 1, 2, 3, 4, 5 here, so the total would be 6. And so to start with, I was just showing building up how you generate the histogram. It's just a matrix. So outer product between each number and compare if it's greater than or equal to iota max omega. So along the rows essentially represents 1, 2, 3, 4, 5, and you're basically asking, is 2 greater than 1 or equal, or is 2 greater than or equal to 2, blah blah blah. Anyway, then you can use this, don't forget the off by 1 error, to index into a 2-element text vector and make, histogram of any pictures you want. And then I was playing around to get a similar representation to what they had, but that's just flipping things around and appending numbers, not that interesting. Then it came to the idea of doing the problem. Yeah, so my two thoughts were like, okay, so I know how to process the image. You basically turn this into a Boolean matrix, but it turns out obviously the idiom generates the Boolean matrix first, so that's fine. And then yeah, some kind of scan, and then just summing things up is what I was thinking. And then I was also, in the back of my head, like, but maybe there's some clever shit you can do with maths and the numbers, and you can be really clever about it. I didn't end up exploring that any further because it turns out that the process, the matrix, the Boolean matrix one was just so elegant. And also, it turns out my recording crapped out. So, I wasn't really planning to investigate the Raku and stuff this week anyway, but now even less so. So yeah, so the first thing I did was make an example with an extra third bucket just to make sure, my logic made sense. And then I sort of flipped the bits around, but this was just sort of me doing a kind of brain wander to see. Because with the ones on this side, you can kind of see the top halves of the buckets, was my thinking. I'm like working towards a scan in my brain. And then this one, the ones represent the details on the inside of the bucket, especially this middle one that has this kind of shape here, right? Anyway, so after playing with that for a moment, I thought, okay, well, let's just try a scan and see what we get. So I did an OR scan first, and this basically all zeros till the first one. No, sorry. It's just, yeah, ones all the way down if there are ones. Yeah, all zeros till the first one, and then ones thereafter. And I was like, yeah, okay. You can see we've removed the details bit, and we've just got information about the top of the bucket. So that's neat. And I tried scanning down. I was like, no, wait. Scan across. Okay, because now this perfectly represents the tops of our buckets. The first bucket goes up to a height of 2. The second bucket is at a height of 4. And the third bucket is at a height of 5. And then I was like, okay, so we got the top of the buckets. Now we need to get these details at the bottom of the bucket. And then I was like, and then little ding, little light bulb in my head is like, oh, the bottom of the bucket is represented by the numbers that you input. So omega, oh no, okay, well, it's more convenient if I do omega subtracted from the tops of the buckets. And that's literally it, right? It's the bottoms of the buckets subtracted from the tops of the buckets. And, you know, it gives you the gaps. It's the, you know, 0, 1, and then there's 3, and then there's 2, and then there's another 2. And it's like, oh. And then, because I read the problem beforehand, what they're actually, all they're asking you for is to sum up all those bits, right? So if the first bit traps 1 unit, the second bit traps 5 units, then you sum up, you get 6. Okay, well, then I don't have to care about the separation of the things at all. I just add this up, and that's the whole thing solved. Yep, that's it. Alright, thanks very much for watching. See you on the next one.